So the point of this video is to teach you how to get the open source physics project program Tracker, which we're going to use to do video analysis. The appropriate Google search is Tracker Physics, and you'll see this website phys-lits.org, and you just go there, and you just pick whichever OS is the right one for you, and you download and install it like you would any other program. If you have any issues, there's a help, just little details that can help you get started. So that's the first step. So at this point, you've already recorded your moving object flying through the air, and it's time to try to get some data out of the video that you made of it. So to find your file, go to Video, Import, and you just look for the video that corresponds to yours. The longer the video, the longer it will take to load. And this is what you'll be presented with. So your video may have any orientation. It depends how your camera was set up and how your camera reported the orientation. If you're not straight up and down, you go to Video, and you go to Filters, and you just look for Rotate. And you pick whichever one's appropriate for you. And then close. So now the video is ready to go. First thing you want to do is you want to find the place where the meter stick is visible, because the meter stick is how we're going to scale. Time data is going to come from the video itself, but the computer has no idea how far away our motion is, so you need to set the scale. So I've got the meter stick visible there. I'm going to go up to this little button here. I'm going to go to New, Calibration Stick. So once you do that, you hold down the Shift key and you click one end of your scale. And I used a meter stick here. It doesn't have to be if you don't have one at your house. Just something you know the length of. Then you hold down the Shift key again and you click the other end. So you hold down the Shift key and click both ends. And then you have to go to this box and you tell it whatever the length actually is. Since mine was a meter stick, I'm just typing 1 meter. So that's big thing number one. Big thing number two, there's no guarantee your camera was straight, so you need to find something in the video that's horizontal, either the lockers or the ceiling or something, and you click on the set of axes here, and the X and Y axis show up, and you just grab the origin and you move it to something you're fairly confident is a horizontal line. And then you can click somewhere out on the x-axis and drag, and you can kind of spin it up and down until you get to the right place. Okay. So now you should find in the video where the motion actually is. And it's probably towards the end. I'm telling everybody in the video how to use the video, so that's why I keep talking. When you get close to where you are, you can step using these controls. And you want to find the one where it's no longer touching your hand. I think that's the one where it's no longer touching my hand. So drag our axes over to where the bird started. Put it right in the middle. And now we can hide the calibration stick by clicking on its button. And we can hide the axes by clicking on theirs. We're going to call this time 0, the original time of our motion. So you go down to this number here, which is the frame number. And you click on it and you click Set Time to 0. And now we're pretty much ready to go. You just need to tell the computer to look for a object. And you do that by going to Create, point mass. Alright, so as it's saying right here, it says shift click to mark. So I'm holding down the shift key, and as I do, the cursor is changing to some crosshairs. You just go right in the middle of the bird. And it auto advances. Notice the bird starts out really blurry, and that's because it's moving really fast in the 0.033 seconds there is to take each picture. So that's pretty fast, but something kind of amazing happens. As the bird goes up, it becomes clearer, which implies it's slowing down. And the reason for that is the force of gravity is getting rid of that initial velocity. And eventually, at the very top, actually brings it to rest for an instant. That's why it's so super clear. Now it's going to continue to pull down, so it's going to speed up in the downward direction. But I always have people remember that the velocity at the top, at the maximum height, is 0 because the object's not going up anymore, so it doesn't have a positive velocity. And it's not coming down yet, so it doesn't have a negative velocity. And I think this exercise really shows that clearly. So we're getting blurry, we're moving faster and faster. And you just keep clicking until you can't see it anymore. Some of you may have less data because, especially if you had a bird that was the same color as your shirt or something, it's a hard time seeing it. That's the last one for me. So now I let up, and it shows the last few points. Now, I've got this nice sort of linear pattern over here. And that pattern actually has some meaning. But if you look, it says time, comma, x. And x is our horizontal back and forth distance. So the fact that that's somewhat linear is very interesting. And it's something we'll get back to in a later lab. But we were interested in y, our up-down distance. We're not as interested in x. To see the y, you go to plot, and you go to 2, and you can see the y information down here. And it's a beautiful looking parabola. And it's a parabola that's going to have a very important bit of information about the force of gravity. So I'd like to study it. Alright, now that you've got all your data, I'm going to ask you to save it in 2 different ways. The first is in Tracker, save project as, and it'll get saved in the same place that you, you click save as and it'll save it in the same place that you got your video file from. The other thing I'd like you to do is go to the table and select all of the columns. And we're going to go up to Edit. And we're going to go to Copy Selected Cells, Full Precision. And then what you need to do is open up a text editor. So not something like Word or Google Docs or something, but on Windows, something like Notepad. So this is my text editor. It's called Pluma. And basically, you're going to paste the data there. And then as you save it, the name you should give it is Angry Bird. And then the extension's pretty important. This will help us open it up in a spreadsheet later. CSV. So go ahead and save it as that. And then you'll have it for what we're going to do with it later. You're going to do one more thing. We're going to get the equation right out of Tracker so we have it. So you do that by going to View, Data Tool, Analyze. And then you're going to click on Analyze, Curve Fits. And right now it's trying to fit a line to that. We're going to tell it that that's a parabola. And notice it has a really good fit. And I want you to write down the equation. So this is in scientific notation. So I would write this as y equals negative 4.446 t squared plus 2.361 t plus 0.005725. So that would be my equation. So after you've written down your equation and you've saved those files, you're all set. We'll take a look at this data in the next class. Thank you.